Hey everybody, thank you for joining us. This is Luke Hasty from Nuaware. Uh, those that don't know Nuaware, we are a partner in the EMEA region. We help large enterprises select, adopt, and implement new cloud native technologies. We've been working in the cloud and DevOps space for a few years, since 2016. We partner with some of what we feel are the most interesting vendors in the market. I'm here today with Sandy Bird, who is CTO of Sonrai Security, and he's going to talk through a little bit about the product and the problem that they're solving. So, Sandy, thank you very much for joining us. I guess first question or first point, would you mind just giving us the quick overview of Sonrai and the problem that you guys are looking to solve?
Yeah, so thanks, Luke, for having me. So Sonrai is really a data and identity governance platform for public cloud. So as people are deploying into AWS, Azure, GCP, or even just Kubernetes workloads in cloud, understanding how identities are provisioned, both people and non-people, finding any risks associated with that around, privilege escalation or separation of duties issues, and then really understanding where your crown jewels are stored in the cloud, what identities have access to those crown jewels, and is there any exposure risk in what you're doing there?
Okay, cool. So when you talk about identities, you're talking individual users, more than individual users. What does identity mean in the world of Sonrai and cloud?
Yeah, and I think this is what's really interesting about cloud is that identity is taking kind of a whole new scope in the world of public cloud. And enterprises, we used to have people identities and service accounts, and that was kind of the extent of it for the most part. When we moved into cloud, we ended up with much better ways of dealing with what were service accounts in enterprises. And there's several flavors of those in cloud. You have to think of everything from, okay, you have identities themselves that have maybe access keys, which are alternative ways to use that identity. You have machine identities, which can assume roles or managed identities in Azure. You have the services in the cloud accounts that actually do things on your behalf. So CloudTrail or API Gateway are actually identities that do things, and they have permissions just like everything else does. So all of those in our world, we call them actors, and they're all identities. And every one of them has different sets of issues that arise, both from the risk perspective and the governance perspective. So it's good you have to keep track of them all in cloud.
So, and the way that you guys go about keeping track of them all is graph based, right? You guys build an identity risk graph. Is that right?
I've been a big fan of graph technologies for a long time. Graphs have this amazing power of creating linkages between things. So in the case of identities, you may have an identity that's a member of a group, but that group has a set of permissions. Those permissions give it access to individual services. Those services have data stored in them, and you can build this long chain of how an individual identity gets access to something at the other end of it. That same graph also allows tying things like, well, that piece of data is stored with an encryption key, and that encryption key also have rights that are tied to a different identity. And because of that, you have separation of duties violations. And you can ask these very deep analytical questions of the graph to understand if you have, risks within this. Now, again, graphs, I love technology. And of course, graphs have some known weaknesses to them when you're doing massive queries against long paths in a graph. So with Sonrai, we've built kind of this interesting API layer in front of the graph, and we actually use multiple different data stores to represent what that graph is that are kind of optimized for their sole purpose. Again, welcome to cloud, where we get to build everything, using fit for purpose technologies. And from the customer's perspective, it's all one API, and they just ask the questions and get the answers.
Sounds straightforward, but
Yeah.
I think we've both worked with enough enterprises in the security space to know that just from you describing the environment, this is complex and there's lots of moving parts and potentially lots of noise. We hear a lot about security tooling out there and alert storms and noise just drowning out what needs to be said. So with such a complicated thing, how do you guys go about making sure people really understand what they need to understand at the right time?
Yeah, no, it's really interesting. And you talk about the alert storms. And actually, Luke, I'm going to try to share something. We'll see if this works here. I'm just going to share my screen. We'll use this as a bit of a backdrop. When I entered this world, I was coming from a pure security background. I've been in security for probably at that time 17 or 18 years. And security teams that have been doing, vulnerability management and incident response for years are actually pretty accustomed to having, 4,000, 10,000 things that they have to do. They stack rank them in a priority list. They burn them down every 2 weeks. New ones show up at the top. They reprioritize. That's the life of a security engineer, and they're very accustomed to that. When we moved into cloud, we found that the whole cloud world was being run by these, you can call them all kinds of different things, cloud centers of excellence. You had, individual DevOps teams that were provisioning cloud infrastructure, but they had power to build their own infrastructure and identities. You had scenarios where sometimes there was a cloud SecOps team that was responsible for the security in the cloud. And it was just a big mixture. And what happened was when customers deployed this, especially people that have been in cloud for 5 years, there was this alert storm. There were 4,000 things that were wrong with what they had done over the last 5 years. And they were like, whoa, I already know I had 500 problems. Now I know I have 4,000 problems. What am I going to do with that? And we built this concept where you could basically, we call them swim lanes. They actually kind of look like swim lanes on the screen here. I'll just highlight one or two, where, you could put your operations team and all of their tooling in a swim lane and understand, what they're doing. Is it secured? Is there any alarms associated with it that maybe they need to go respond to? Are there issues from not only a governance perspective, but an incident response perspective? They have machines reaching out to Tor networks or something. And it would be isolated just to the operations team. And then you could take, the data, regulated data, that, highly sensitive data, and you could put that in a swim lane, and you could say, you know what, the only thing that the data governance team really needs to know is there a violation with that regulated data? They don't care that there's a sandbox sitting around somewhere with administrative rights and data being copied in or out of it. It's not regulated data anyway, so it doesn't matter to them. So their swim lane looks very green because the only thing they're worried about is that one, piece of very sensitive data. And apparently in this case, there's an encryption issue with it, according to what's showing on the bottom there. And you can do the same thing with individual development teams. You could have dev team one, and apparently those guys don't do a very good job because they got a lot of red and orange bars here that they've got to go fix along a lot of different issues. But by doing that, it allowed us to take those 4,000 issues and really tell from the top level of security, here's the one thing you need to go solve now, right? You've got a regulated swim lane. It's got an encryption issue that needs to be solved now versus, dev team one, you guys kind of suck. You've got massive identity risks, as you can see by that last orange bar there, that you need to go deal with. And it can just give them the couple of issues they need to solve versus the entire company's cloud infrastructure. And it was life-changing for our customers. As opposed to now having those 4,000 things that they needed to do, they could divide up those low-level issues that needed to be cleaned up back to the teams that were responsible for creating them in the first place. And the truly sensitive stuff, or somebody decides to turn centralized audit off for the whole cloud infrastructure, that gets highlighted to that, whatever cloud center of excellence or the cloud SecOps team or whatever they happen to be calling them this given day. And it just made a huge difference, across the board from that perspective. So swim lanes are huge. We already know that we need this kind of push the problems to earlier parts in the development cycle. The problem with the cloud infrastructure is you can lint your Terraform templates, you can lint your CloudFormation. When you have code that's creating infrastructure, it's sometimes hard to know exactly what that code is going to create in a live environment. So you need to have these concept of development accounts and non-prod accounts where you're testing this, making sure it's passing and everything's green before you promote that code to the next stage of production, right? And that's a key part of the solution, and being able to check that stuff before it gets deployed into the wild. It just becomes part of your standard automated test suites as you're deploying any new infrastructure out. So.
Great, thank you very much. Summary, you guys talk about two things a lot: identity and data. And you mentioned crown jewels data. What do you guys mean by that? How do you view and link the two concepts of identity and data? And it comes back down to sort of where's the company come from a little bit. Yeah, would you mind just going through that in a little bit more depth?
Yeah, no, certainly we started on the data side. So for sure, we understood in cloud, there were there was nowhere to hide the data anymore, unlike an enterprise, because there was a bill associated with it and somebody had to pay for it, we could go find it. And because you could find all of the data, you had the opportunity to classify that data and understand what it was. You could calculate the access rights to that data. You could figure out what identities, both machine and and people identities, had access to it. And you could understand things like separation of duties violations, like does the same person have the ability to turn audit off, read all of the data, and then turn the audit back on? Or, have you got that separated across a couple of individual identities? And so the graph really allowed us to do that, both ends. Start at the data, find out all the identities that have access to it, start with the identity and find out all the resources in cloud that they have access to and what they can do to them. And by having that graph work in both directions, it really gave us the power to solve a problem that was currently kind of unsolved in cloud. And every cloud's different. In AWS, it's actually really hard to start at a piece of data or a resource. It doesn't have to be data. It could just as easily be a piece of compute. But the reality is any resource in cloud and calculate every identity that has access to it is almost an impossible problem to solve. In Azure, that's actually an easier problem to solve because of RBAC assignments and things like that. You can kind of figure out what the permissions are. But it's almost an impossible problem to start at the other side. To start at Luke's account in Active Directory and say, show me everything in all of Azure and all of the directories that Luke has crossed into that he has access to, is an almost impossible problem to solve. So it's, both sides of this, and building the graph really allowed us to solve it in a multi-cloud way, where it didn't matter if you were using Azure or AWS or GCP or even, Kubernetes with a bunch of its identity stuff on top of it. You could basically build in, your separation of duties rules and test those independent of the cloud, which was really interesting. Luke, sometimes it's fun to show visuals of this stuff. So why don't we do that for a second?
For it. Yeah.
Again, it's graph. So the great thing about graph are you get lots of great visuals. So this happens to be a person identity. So it's Bill Smith. And, Bill's got a couple of interesting things. So he's got, a bunch of different kind of permissions that are directly attached to him. He's also in a couple of groups where he's in a DevOps group and an infrastructure group. He's got a bunch of different roles he can assume based on that across multiple different accounts. So you can see he's in this demo account, he's in the security account, and he's in the production account. And with all these clouds, there's the concept of, denies and policies and security controls that block things. So this has SCPs associated with it as well. So maybe there's some SCPs, we could bring these up, they're kind of boring to look at, but, that denies, creation of CloudTrail as an example. So Bill Smith can't do that, even though he theoretically has access to do it with maybe some of these controls. He can't because he has an SCP that's blocking it. So that actually gives us all of his permissions. But what's more interesting is that it gives him access to data. And these are the data stores that he has access to. And you can see there's all kinds of different data stores here. He can do different things to them. So he can sometimes create new data, or he can delete data, or he can restore something. Again, the clouds have tens of thousands of different permissions. We sort of categorize those into read, delete, your typical CRUD operators with some flavors around data and protection there. But if you want to understand, how does Bill get access to this? All of a sudden, remember we mentioned that he was a member of the DevOps group. Well, that's giving him permission to do an assumed role. He can jump into these other roles, and depending on which role he jumps into, he gets different permissions, which allow him to get to that, in this case, a DynamoDB table with customer data in it. And that's how that path works to get there. So rather you started at Bill Smith finding out he can get down to this piece of data, or you started at the customer data and finding out all of the identities that can get access to it, the graph allows us to build those. And again, this is a great visual way to represent it. From a customer's perspective, these are just things that show up back on this, graph that we showed earlier that says, there's an overprivileged user in this given swim lane that is allowing access to data that it shouldn't, as an example. So those are the types of things that, from an identity perspective, are very powerful in the solution and allow us to answer those complex questions that people ask.
Thank you. I do love visuals, so thank you very much for that. I guess last question then, Sandy, is let's say I'm in an organization, I'm a cloud architect, security architect, DevOps team lead. It could be any one of a number of people that could be interested in solving this problem. Is there any one thing that they can go away and do to see, are they impacted by this? How do you know if this is a problem or not?
Yeah, there's in almost every account, it's definitely a problem. If you have AWS, you really need to understand, starting with your trust relationships and what's behind the trust relationships. Amazon's supplied some pretty basic tooling using IAM access analyzer where you can say, oh, this particular role or this particular key has rights from another account. Unfortunately, that's the end of the graph for them. You know, okay, well, what's in the other account? Are there 100 users over there that can access it? Is there a, you know, a build workload that can do it? What's on the other side? You need the graph to figure that out, but you can get started seeing how much your exposure is using even that basic tool. There's some open source tools that actually try to build, at least within one account, privilege escalation checks and things like that. So some open source tools to get started on those. And that gets you started. You know, from there, you know, if you find you have issues, which almost everyone does, then it starts to get to the point where you need to deploy something on top of that. And again, we've got some great opportunities for customers to do some kind of risk assessments using this in a very easy way. And then, you know, if it makes sense, we figure out where to go from there. So.
Perfect. And I guess all of that's available on your website, sonraisecurity.com. That's about it from my side, Sandy. Thank you very much for joining us. Hopefully that's been useful for everybody. Yeah, if you're interested in finding out more on this topic, visit the website or drop me a note, and hopefully set you up with Sandy and the team to find out a little bit more about Sonrai and the problem of identity in cloud. So thank you very much.
Thank you, Luke. Have a good day.
Thanks, and you.